So let's take a look at 3.7 families of quadratic functions. And when we take a look at families of quadratic functions, we're going to take a look at the three forms of a parabola. In group number 1, this is in vertex form. F at x equals my a value, x minus r, x minus s. And r is your first x-intercept, s is your second x-intercept. In group number 2, these functions are in vertex form. And obviously you know that because you have a x minus h squared plus k, and in group number 3 you have standard form. So let's fill this table out here. It says in group number 1, these functions all have the same, and in this what varies is your a value. Your a value will vary at times, but what's going to be the same are your x-intercepts. And because your x-intercepts are the same, that also means that the equation of the axis of symmetry is the same, because the equation of the axis of symmetry is always found using the two x-intercepts. What's different though is your a value. And your a value can vary. Sometimes it may be a vertical stretch or a vertical compression, and that will make your a value vary. Now we're going to get back to this part of this group later on, but it's very important you understand that all the families in this group have the same x-intercepts. It's your a value that may change. Now if you take a look at group 2 and you look at vertex form, again vertex form, the exact same thing. The things that are the same are the vertex, because they will actually give you an h in your case. So the vertex will be the same. Obviously if the vertex is the same, then that means the equation of the axis is the same, because the vertex is always on the equation of the axis of symmetry. What is different, again, is your a value, and your a value will always be different, maybe a vertical stretch or compression. Again, we'll get back to that later on. Group number 3, obviously in standard form, and of course what is the same of anything that's given to you in standard form? Of course your c value will be given to you, and that is your y-intercept. We can tell you what the y-intercept is right away when we're given in standard form. Of course, what else is the same is your equation of the axis, because we know that the equation of the axis of symmetry can be found using x equals negative b all over 2a. Okay, so we'll get back to this as well. Again, your a value will be different. Okay, and if we take a look at the first example here, it says, first it says equations of parabolas or objects with parabolic shapes can be determined as long as we are given a point xy on the parabola and either the x-intercepts or the vertex. Okay, so it says just substitute the given point for x and y into the general equation for that family and solve for a. So let's take a look at example 1. Determine the equation of a parabola with x-intercepts of -4 and 3, and it also passes through the point 2, 7. So your x-intercepts are -4 and 3, and it passes through this specific point. So we already know that a parabola in x-intercept form is written this way, and they're giving us the two x-intercepts of -4 and +3. So we already know, I don't know what my a value is, but I know that this is going to be x minus my first x-intercept is -4, and then x minus my second x-intercept is +3. Continuing this, that gives us y equals a x plus 4 and then x minus 3. So this is pretty much, this part here is pretty much the equation for my parabola in x-intercept form. The only thing I'm missing is the a value, so I have to rewrite this with the proper a value. Now that's where this point comes in, because it's telling me that a point on the graph xy is 2, 7. That means when x is 2, y is equal to 7. So I'm going to plug that in to this formula to figure out what a is. So I'll use this formula, y equals a, and then I have x plus 4, and then x minus 3. And so if I plug this in, I'm going to get y equals a, x is 2 plus 4, and then x is 2 minus 3. I actually forgot to plug in that y is 7, so I'll write that down over here. And then I have to solve for a here, so I'm going to get 7 is equal to a times 2 plus 4 is 6, and 2 minus 3 is negative 1. So I'm going to end up getting 7 is equal to negative 6a. If I divide the negative 6 from both sides, I'm going to get that a is equal to negative 7/6. Okay, and so that's what I'm going to write here. My final answer will be y equals, and then my a is negative 7/6 x plus 4 and x minus 3. And this is in fact my final answer here because it has the proper a value. Now let's take a look at the next example on the second page here. It says, example 2, determine the equation of the parabola with vertex negative 2, 5, and that passes through the point 4, negative 8. So this time it's actually telling me what the vertex is, and we know that the vertex is hk. So obviously, in order to come up with the equation for this parabola, we're going to have to use the vertex form of a parabola. And vertex form of a parabola looks like this. Now, of course, we have h and k, so this is going to be y equals a, x minus, and my h is negative 2, all squared, plus k is 5. So I end up with y equals a x plus 2 squared plus 5. So this is the formula for my parabola, but the only thing I'm missing is my a value, and I need that. So this is why they give you an extra point on the graph. A point that they give you on the graph, xy, is 4, negative 8. So when x is 4, y is negative 8. So I'm going to use that formula of y equals, and I'm going to use that formula there, a x plus 2 all squared, and then plus 5. So plugging in my 4 for x and negative 8 for y, I get negative 8 is equal to a, x is 4 plus 2 all squared plus 5. Continuing, this is negative 8 equals a, 4 plus 2 is 6 all squared plus 5. So I'm going to get negative 8 equals, this is going to be 36a plus 5. Bringing the 5 over to the other side, this is going to be negative 8 minus 5 equals 36a. So then negative 8 minus 5 is negative 13 equals 36a. And I can divide the 36 from both sides. And so I end up with getting a equals negative 13 over 36. And that's my a value. So now I can rewrite my proper formula as y equals negative 13 over 36 x plus 2 all squared plus 5. And this is in fact my final answer with my proper a value there. Of course, you can write this in function notation. This doesn't have to be x's and y's. It could be f at x and x. And you can also write, height as a function of time or whatever you're dealing with. So let's look at example 3 because that is more of a real-life problem. So it says here, a hose sprays a stream of water across the lawn. The table below shows the approximate height. So it says approximate height. So that's very important. Approximate height of the stream above the lawn at various distances from the person, sorry, that should just say from the person. So from the person holding the nozzle. While an algebraic model, write an algebraic model in vertex form that relates height of the water to the distance from the person. So as you can see, we have a table of values going sideways. Here are your x's and here are your y's. And this is a real life situation that they've approximated the height and they've carried out this experiment. Now, if you're carrying out an experiment, the numbers may not equal an exact parabola. But if I take a look at these numbers and I take a look at my x values and y values, some of you may see this better if you write a table of values going this way, and that's perfectly fine. If you wish to do that, you can do that, but I can see it this way. Some people can see it this way. But if I take a look at the y's, the height goes from 0.5 higher, 2.6, higher to 2.9. This is actually the highest number, 3. Then it goes back down to 2.9, 2.5, 1.9. So just judging by what's going on here, the highest height is 3. And we know that the vertex of a parabola is either your highest or lowest point. So I can make the assumption that this is the vertex because that is the turning point of this parabola, or parabolic shape, or what is very close to a parabolic shape. So my formula is going to be in vertex form. I'm going to be writing this, vertex form of a parabola. And then I'm going to plug in that my h value is 5 and my k value is 3. So this will be x minus 5 all squared plus 3.0, but I'll just write 3. And so this is my formula in vertex form. However, I need my a value. So in order to find the a value, I'm going to have to plug in another point on the parabola.